Look at multiplexers. Multiplexers look like this. It will be having a like this, and it always have 2 power in input, 2, 4, 8, something like that. So 2 power values, and the output always 1. And here it will be connected with the select or control. Okay, so this is how multiplexers look like. Now let's look at 2x1 multiplexer. I'm gonna go ahead and create a new page for it. Okay, let's look at a 2x1 multiplexer. So for this one, we have 2 input, 1 output. Let's say the input is A here, B here, and this is 0, this is 1, and this is a 2x1 max multiplexer. And for 2x1 multiplexer, when S is equal to 0, what is this? To see what is this, I am going to actually draw this one in terms of logic gate diagram. If you draw this one in terms of logic gate diagram, this is going to look like this. You're going to have 2 AND gates, and then here you have an input A, and then here you will be having a NOT gate connected to this, and then this will be connected with an AND gate, another AND gate, and here this is B, this is S, this is selected signal, and these two will be connected to an OR gate. And this is the output. Whatever the output we are having right here, that's the output. So this is the logic gate expression for this multiplexer, 2x1 multiplexer. Now here what does this say is that when we have this S is equal to 0, we will be having output at pin is equal to 0. Output is equal to 0, and when S is equal to 1, the out pin is equal to 1. Okay. So what does it say? So in other terms, if you want to write it, when S is equal to 0, the output will be whatever the value we have in pin A. Okay. And when S is equal to 1, the output is whatever the value we have in pin B. Now let's see how to see this. For example, if you put this logic gate, right? Let's put the first condition in the logic gate. If I have a 0 here, what's going to be the value here? This is going to be 1, and here we are going to have 0, and 0 going through an AND gate is going to give the output of 0. So this is going to be 0 right here. The input here is going to be 0, but here if you have a input 1 right here in an AND gate, whatever the A value holds, that's going to be the output right here, right? And when A and 0 goes to the OR gate, A will be the output. So that's how we derive the when S is equal to 0, the output is going to be whatever the value we have in pin A. That's how we got this. So if you have 0, you're going to get 0 already. If you have 1, you're going to get 1. So whatever the input you put, that's going to be the output. Now let's look at the second condition. The second condition says whenever we have 1, S is equal to 1, the output is going to be equal to whatever the value we have in pin B. So for example, I put 1 here, right? S is equal to 1 here. what's going to be the value that's going to come here is going to be 1, and here is 0. And you can see here we have A and 0, and in AND gate, if you have a 0, that makes the whole thing 0, so the output here is going to be 0. And here, if I have 1 here and B here, if you have 1 and B going through an AND gate, the output is going to be B. So if the B and 0 goes through an OR gate, the output is going to be B. So that's what this one, like when S is equal to 1, the output is going to be whatever the value that's in B. And that's basically it, and I'm going to go ahead and continue this one with my next video. Thanks for watching, guys.